अस्सलाम वालेकुम।
वालेकुम सलाम, कैसे हैं?
ठीक हूँ, आप कैसे हैं?
ओके, मैं भी ठीक हूँ। लेट्स सी, कैन यू सी माय स्क्रीन?
Yeah.
प्लीज रीड।
All right. So Sokoto transport, sorry, passport to the world of trigonometry.
Okay, so this is very interesting. But you're reading that, so it has a story. So I will
Okay.
the story later on, and it's a very meaningful things. So Sochchtoa. So this is all about that. It's a very interesting story about this mathematician. So I will tell you the story later
Okay.
on, but now we are just going to continue this, the word of trigonometry. So this was
Okay.
the last time we skipped the question. So
Right, we did.
please read this one.
Sure. None of these is a triangle. Can you tell why not?
Yes,
Do you want me to answer that?
yes, you can respond to the
Yeah.
question.
Okay. So, there's no like shape there that has only three sides and is connected, like all
Yes.
together are connected.
So basically, the triangle is three-sided closed figure. So
Right.
sometime we are getting three side, but the polygon is not closed. Sometimes we are not getting the straight lines. So anyhow, these are not the triangles.
Yeah. Click on each one that is a triangle. So I'll just tell you. It's the one all the way to the left.
Yes, this one,
The really long, yeah, the really long one, like the stretched
this
out
one,
one.
and
Yeah, and then the
this.
top right.
Yes, but this is not triangle once again. So we have only three
Yeah.
one. Okay, now let's see.
Yep.
The next is, please read
A
this
right
one.
triangle. Okay. Right triangles. A right triangle is a special triangle that has one of its angles a right angle. You can tell it's a right angle when one angle measures 90 degrees, or the right angle is marked by a little square on the angle whose measure is 90 degrees.
Good. It's a self-explanatory. Nothing to say more or less
Yeah.
than that. Okay. Look at this.
Okay, these are right triangles. Can you tell why? Because the square marking on the triangle base thing indicates a 90-degree angle. So it makes it a right triangle.
Yes, it's a good reason.
Yeah. These triangles are not right angles. Explain why not. Because there's no like indication for a 90-degree angle in any
Yes.
of them.
Yes. Basically, there is no sign of that square that may be slightly less or greater than 90 degree. It's obvious.
Right.
It's a acute angle triangle. None of the angles measuring 90 degree. So once again, here we are just a little bit confused that it may be greater than 90 degree. So that's why
Right.
this is the explanation that why these are not the right angle triangle. Anyhow, let's see. This one is
Click on the triangle that is not a right
okay.
triangle.
So let's see
The
which
two
one
without
is.
the two without the square symbols.
Yes. So this one is absolutely right. We can say this one. And
Yeah.
this one also is a right angle triangle. And this is also a right angle triangle. Okay. And here we
Okay.
are not sure about that angle.
Yeah, because it's yeah,
And
because they're not
this,
always drawn to
oh,
scale.
yes. And this is once again acute angle triangle. Every angle is less than 90 degree. So we have
Right.
only three tick marks. So let's see, just to the next one. So, okay. So this is the, let's see, please read this one.
The hypotenuse, the longest side of a right triangle is the hypotenuse. The
Yes.
hypotenuse directly lies directly opposite uh directly opposite the right angle. The legs may be equal in length or one may be longer than the other.
So I think these three things are enough to define the hypotenuse. So
Yeah.
hypotenuse is the longest side, and that is the opposite to the 90-degree angle. Whereas there is a 90-degree angle, the triangle will be right angle triangle, and there is a opposite side that is called the hypotenuse. Okay, now let's see. The next one is
All right. A right triangle has two legs and a hypotenuse.
yes. So this is the one leg, this is the second, and hypotenuse. Now let's
Right.
see. The next one is
Click on the side that's longer, the longer leg of the right triangle.
so this is side number two is the longest. Okay,
Wait,
that will become
wouldn't
the
the leg is the hypotenuse a leg
or try it
or
yourself longer leg. Longer leg. Click on the side that is the longer leg of the right angle triangle. So longer, I think you are
it'd be
little.
side one, right?
This one is the longer,
Because yeah,
longest.
no, it's not the longest, but is a hypotenuse a leg too, or
Leg 2 is a hypotenuse because it's opposite to the 90-degree angle. Can you see this?
okay, yeah, yeah. I was asking a different question. I was asking if a hypotenuse can be a leg, like because I thought the legs were the ones that aren't opposite
Okay,
to a 90
okay,
degree.
okay, okay. What you are talking about, that was in the previous slide, the leg is over there. But hypotenuse cannot be a leg in the sense because it's a spatial name. You can see just if I'm just going to the previous one, so you can see that is what we're calling that the legs. Okay, look at this.
Okay,
So these are the legs. So this is the
okay,
leg one, leg two. We cannot say the leg over here. In the
yeah,
sense,
that's what I
why
was thinking.
why we are not saying, because the legs cannot be just like in this position. That
Right.
the leg is just the sporting one. So
Yeah, that's why I
this
said
is,
so it'd be
and
side
this
one.
sport in this one. Anyhow, we cannot say the leg to this side. It's a special name, and these are also have the special name. We will just talk about those. Definitely they will come. So once again, we can sides, it's absolutely right, there's no harm to say side. And look at this. So if we are just from where this was the question, the hypernews, the this was, and then we were going over here, this side, click on the sides that is the hypotenuse of the right angle triangle. So which one is the hypotenuse?
The hypotenuse is side two.
Side 2, absolutely right, because it is the longest once again, and it is also opposite to the right angle, so that's why it's a hypotenuse, like 2 or a side 2. Look at this. Click on the side that is the shorter leg of the right triangle. Which one is the shorter?
Three.
3. 3 is the shortest. Okay.
Right.
Try it yourself. Longer leg. Which one is the longer?
A longer leg is side one.
Side one. Absolutely right, because this is the hypotenuse. We cannot say it a leg.
Yeah.
Okay. Pythagorean theorem. Please read
Right.
this one.
Okay. The right triangle has a special property called the Pythagorean theorem. It can help us find one side if we know the other two sides.
Yes.
If
Yeah, I think you are recalling now. It's a, just a
yeah, I know. Yeah,
oh, you are recalling the
I
things.
remember. Yeah.
Anyhow, look at this diagram, and just this is leg 1, leg 2, hypotenuse, and denoted by A, B, C. If the lengths of the hypotenuse and legs are C, A, and B respectively, then the square of C, the opposite side to the 90-degree angle, is always equal to the sum of the squares of the other two sides. Are you getting this?
Right.
It's a very
Yeah.
simple hypotenuse theorem. Anyhow, Pythagoras theorem. Next
Right.
is
Use
finding
the
a side.
Pythagorean
Yes.
Use the Pythagorean theorem to find the length of the missing side.
Okay. So how can you do this?
Uh,
C square is, this is the theorem,
right.
and here C is replaced by X. So X square,
Okay.
and the square of the
Yeah.
other two sides, and 17.2. I think it's a very much obvious.
Yeah.
Once again, now this time what you are
Right.
looking for, you are looking for the leg.
Yeah.
So this theorem as it is, we will have to shift. We are looking for X. So this will come over here. This will be negative, and what you will get, we will have to subtract 100 from 225. So we will get the answer. Anyhow, try yourself to iron is fine. Okay, how can you find this? If you have a calculator, do you have?
I don't have a calculator on me, no.
Okay, okay. Anyhow, it's not in handy, so you can make the calculation. You will have to click the selection that matches your answer. Which one is your answer?
Uh, well, so it'd be 6 squared uh, plus 8 squared, right?
Which one
And
is
then,
your choice?
1 second. If the length
Which?
of the,
This, or this?
I think, would it be B?
Oh, yes, absolutely right. Because 36 plus 64 is 100, and the square root of 100
Right.
is 10. So this time this is the correct answer. So we are just going to the next one. That is the, okay. Let me clear this. Okay. Now, what is that? So click this selection.
Okay, find the leg of the given triangle with the known legs. Okay, so that would be 15 times 15. Okay, and then plus 9 squared. What is it, 12D?
12t. If you are getting
Yeah,
144,
D.
144, 220,
Divided by.
220, 225 over here. Am I right?
Yeah. Yep.
And then 81 is this. 225
Yeah.
minus 81. 225 minus 81 is 144. So the square
Yeah.
root of this 12. Okay, this is simple. Anyhow, opposite or adjacent sides. Now, this is most important. But I can say that here we will have to make the what we can say the conclusion all about that the ratios. Anyhow, please read this one.
Okay, in a right triangle, given leg is called the adjacent side or the opposite side, depending on the reference acute angle.
Yes. So triangle, you are looking at this, so you will have to read this also.
Okay,
Please.
adjacent or opposite from an acute reference angle refers to only legs and not the hypotenuse.
Yes, of course. So whenever we have, one is the right angle over here, this is the right angle, and these are the acute angle, because the sum of the three angle is 180 degree.
180, yeah.
So both are the acute angle. With reference to any acute angle, we called it opposite to that acute angle or this acute angle. So that's why you will have to say adjacent. Look at this. The triangle is in front of you. So with reference to A, which one is the opposite angle and which one is the adjacent angle?
So, opposite is gonna be from A, it's B, and then adjacent is. Would it. Wait, can adjacent. Adjacent can't be, what do you call it? the hypotenuse, right?
No, that's the opposite to 90 degree. Forget about that. That adjacent and opposite side cannot be the hypotenuse. We have only the two choices, the leg one and leg two. So you will
Okay,
have
yeah.
to
So it's leg one,
leg one is
opposite. Oh, sorry. Yeah.
leg one is opposite
Yeah,
to
right?
which angle? It's opposite
To A.
to A. Leg one is opposite to A. Look at the figure.
Leg one. Oh, no, it's adjacent. It's the right. Oh, my.
So with reference to angle A,
I was looking at side A, but yeah, it's still, it's leg two is opposite.
leg two is opposite. And what about the leg one?
Yeah. Leg one is adjacent.
Adjacent. Okay, good. So hypotenuse cannot be opposite or adjacent to the acute angle, what I mean to say. Now look at this one.
Okay.
Please read this.
All right. In a right triangle, a given leg is called the adjacent side or the opposite side, depending on the reference acute angle. Leg 2 is opposite to acute angle A, and then leg 1 is not opposite to acute angle A.
Okay. Then look at this.
Okay. Uh, in a right triangle, a given leg is called the adjacent side or the opposite side, depending on the reference acute angle. Leg 1 is adjacent to acute angle A, and leg 2 is not adjacent to acute angle A.
Good. Hide yourself. Opposite.
Okay. Okay, so click on the side that's opposite to angle B. Angle B, it's leg 1.
Leg one. Absolutely right. Hide yourself. Adjacent.
Adjacent to angle B is leg 2.
Leg two with reference to angle B.
Angle B.
Okay. Please read from the top. Trigonometric
Sure.
from here.
Trigonom- Trigonometric ratios of acute angles of a right triangle. The ratios of the sides of a right triangle have special names. There are three basic ones we will consider: sine, cosine, and tangent.
Okay. From here, please.
Okay, the sine of an acute angle. Let the lengths of legs be A and B, and the length of the hypotenuse be C. A is an acute angle. With reference to angle A, the ratio of the length of the side opposite angle A to length of the hypotenuse is defined as sine A. Sine A is equal to length of side opposite divided by length of hypotenuse. Wait, what does that
Yes.
say? Equal A over C?
Yes.
Okay, and then sine A is abbreviated SINA, and then thus sine A is equal to A over C.
Okay. Now, this is the first ratio. So, how can you explain this?
So sine, it's you take the opposite leg and you just divide it by the length of the hypotenuse.
Good. Absolutely right. So, with reference to the angle, if I am saying that you will have to find the sine of this angle, it's a B or theta, then what is that? Sine theta. Theta is over here. My arrow is
So
there.
that'd be B over C, right?
Okay, absolutely right. So this is the requirement that you must know about the ratios. The cosine. Please read this one.
The cosine of an acute angle, let the lengths of legs be A and B, the length of hypotenuse be C. A is an acute angle. With reference to angle A, the ratio of the length of the side adjacent to angle A to length of the hypotenuse is defined as length of adjacent side to angle A over what is that? Oh, okay. over length of the hypotenuse, so B over C. And then cosine is abbreviated as COSA, thus cosine A is equal to B over C.
So, how can you explain very briefly?
Yeah, so the side, so basically when you take the cosine, it's the adjacent, um, like the adjacent side divided by the hypotenuse.
Good. So, cosine is the ratio between the adjacent to the hypotenuse. Am I right?
Yeah,
Okay. So, now the next one is, please read from the top.
sure. The tangent of an acute angle. Let the lengths of legs be A and B, and the length of the hypotenuse be C. A is an acute angle. Um, with reference to angle A, the ratio of the length of the opposite angle A to the length of the adjacent angle. Adjacent to angle A is defined as tangent A is equal to the length of the side opposite to A and length of the adjacent. So it's A over B. And then tangent A is abbreviated as tan A, thus tan A is equal to A over B.
So, in a single sentence, please.
So it's the opposite, um, so the opposite side over the adjacent side, which like divided by pretty much.
So, tangent is the ratio to opposite to the adjacent. Am I right?
Yeah, pretty
Tangent
much.
is the ratio between the opposite to the adjacent side. Anyhow, so very simple, and that's why I'm not speaking much more about that because it's self-explanatory. Get to know. Oh yes, this was the word. We have started from here. Am I right? Isn't it?
Yeah, yeah,
We have started SOA, CAA, CAHTOA, Soha,
yeah.
Kaha, Toa, whatsoever the pronunciation is.
Sakatoa, yeah.
Okay, okay, anyhow. So get to know this. I will send you the story also. Okay? That
Okay,
story will be recorded in your voice. What I mean to say, I will display the text sentence by
okay,
sentence, and you will have to read that, and that will be recorded, and then we will publish it. That will be the
sure.
interesting story in your voice. Okay? So
Yeah, that sounds
that
good.
is a story. Anyhow, now look at this. Please read this one.
Okay, so SOH is sine opposite hypotenuse. This is clever technique most people. Oh wait, I should probably read all the
Yes, please
abbreviations,
read
right?
this one. Read this one. All these are very important.
Okay. So cosine adjacent hypotenuse, and then tangent opposite adjacent,
So these are
and
the
then
three ratios. So SOH, talking about the first ratio. When you are just keeping this in mind, SOH, CAHTOA. So that will become sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. Hello, are you getting these
right,
code words?
and then adjacent. Yeah, yeah, yeah,
If you are calling,
yeah. I get it.
if you are
It's
looking
just a
for
short way
sine,
to remember these.
if you are looking for the sine of any triangle, so what you will have to do? SOH. If you are looking for cosine, CAH.
Yeah,
If you are looking
sine.
for
Yeah,
tangent,
sine.
TOA.
Then
Okay, please read this one.
right. Okay. This is a clever technique most people use to remember three basic trigonometry ratios. Sokotoa sounds strange. What if I told you it was ancient Oriental queen who loved geometry? Not true.
Anyhow, it's maybe a fictional or imaginary story, but anyhow, I will definitely tell you this story. Anyhow, so next, I have a story, interesting story. So that's why. Okay. Click to the
Okay.
next. So any confusion over there? Now you're getting this.
Yeah, I'm starting to get it. Yeah, we did this already, but I just forgot about it.
Okay, okay. Well, anyhow, SOHCAHTOA. So this is all about the trigonometry. If we are just keeping all these things in, we never missed any ratio in any given triangle, right angle triangle. We will get the right things over there. So that was the last time we have a problem. We skipped that because
Right.
that time you were not with me that what is the ratio, cosine, this is. Anyhow, next is please example. Read from
Okay.
this.
Example of cosine. Wait.
Sine.
Example sine, cosine, and tangent ratios.
Yes.
Sine b is uh equal to opposite
Once
over
again, you are
hypotenuse.
missing this. Find the sine of the given angle about this. SOAHCAHTOA. So let's see. This is a given angle.
Okay. So where do you want me to start reading? Just sine b is equal to opposite ratio of opposite and hypotenuse. So
Yes.
sine is 53.1 degrees, which is equal to 16 divided by 20 equal to 4 over 5, which is 0.80. And then the cosine is equal to a cosine of b is equal to adjacent ratio of adjacent and hypotenuse, and then 12 and 20, and then it goes down to 3 divided by 5, which is 0.60.
Yes.
And then tangent b is equal to opposite divided by the adjacent of b, and then 16 divided by 12, which simplifies to 5 divided by 3, which is 1.67.
So this is all about the triangle. Okay.
Right.
So the angle is given. This time this B is given. So we are making use of so-called whatsoever is
Yeah.
this. So that is the practical use of this over here in this triangle. Anyhow, try to yourself trigonometric ratios. So this is your
Okay.
time. You will have to select out of
Sure.
these out
All
of
right.
these for each and every value. So this is the
All
triangle.
right.
Each and everything is given.
All right. Let me do these then. Right. So that is sine. Opposite is 12 divided by hypotenuse 15. Um, okay, that goes down to point 0.8, which is, oh, we're not gonna go down to that. Okay. Six, okay, that is. Do you want me to do all of these and then tell you all of them, or do you want me to do like
No, no, no. What you will have
one
to
at a
do, you will
time?
have to select, you will have to rematch from A, B, C, D, E, F. Which one is the
But do you want me to do all of them or just one at a time?
one at a time? You will have to find the sine, cosine, and tangent one by one. Sine,
Oh,
what
okay.
is your
So I'll tell you what I got for sine.
yes?
For sine, I got 4/5. So which
4 over
is
5. 4 over 5 is where? This even.
e. Yeah,
This is your choice.
yeah.
Okay. Now let's see. The next one is for the cosine.
All right, let me do that one now. Sine, which is a b, 9, 10, 1 times 3, and 3 times 5. I got 3 divided by, so 3/5 for that one.
This one.
Yeah,
Okay. Last one
and
for
then
the
tangent.
tangent.
Okay, it was opposite first. 12 divided by 9, 4 over 3. Okay, so that's C.
C. So this is your answer. So what you
Yeah.
are making use of this for the sine opposite hypotenuse. opposite, and this is the hypotenuse.
Yeah.
Okay, 12 over 15. And for the cosine, A adjacent to the hypotenuse. And for the tangent, T opposite adjacent. Am I right? You are
Right.
using
Yeah.
you are using this one?
Yeah. I'm using yeah, I'm using the ones that like so for cosine I'm using CAH, and then tangent I'm using TOA.
Oh yes, of course. So that's why this must be in your mind so you can solve any triangle. So I'm sure that if you're using
Right.
all
Yeah.
these, so you're getting the right answer. Absolutely right. Okay.
Yeah.
So the next one is, so this is the next one. Angle or side lengths. Please read this one.
Sure. Does the is that triangle or
Trigonometry.
trigon? Okay. Yeah.
Trig ratios.
Trigon. Yeah. Ratio depend on the size of an angle or the size of the side length. Let us consider similar triangles in our investigation.
So what's your answer is what you are thinking about?
It's.
Does the
I
trigonometric
think it's.
ratio depend on the size of the angle or size of the side length?
It's the side length because the triangle things stay the same.
Similar
Like the angle
triangles
stays
are
the
there.
same.
Similar triangles. What do you mean by similar triangles?
I'm saying that their angle measures are the same.
Oh, their sides are different. The sides measures
Yeah,
are different, angles are same, then we can say it's a similarity of the geometrical figures.
yeah.
So what we can say that it's depending upon the trigonometric ratio, depending upon size or angles,
Size
depending
is
upon
the
the
sides.
size of
Sides,
the
yeah.
length of the sides of triangle. From here we can say we will get a different value for this angle, we will get the different values for this, and we will also get the different value for this triangle because these are the ratios to the
Right,
sides. Ratios to the sides are called trigonometric ratios.
right.
Ratio is always between two things.
Yeah,
So find the trigonometric ratios of each. Remember this one. So
right.
this is just like that. So from here, the sine of this angle. So opposite to the hypotenuse. Then
Yeah.
this, and this. So every time what you are getting, the
The same.
different answers. Am I right? What are you getting this?
Oh, right, right. Yeah, yeah. Yeah. We're a different answer for each like thing.
Are you
But
sure
like
we have the different answers?
actually no wait. Oh, I'm reading it wrong. No, they're all different for sorry, the same. They're all the same for like the sine, cosine and tangent.
So we are mixing over here. What last time what we were talking about that?
Oh, I before I thought that the side length would change that what you call it? Like the side length would change the sine, cosine, and tangent, but I
And
guess
when we
not.
are actually calculating what we are getting,
The same exact answer.
the same values for every triangle. It's astonishing. What's
Yeah,
happening? What's happening? What is the secret behind that?
that the ratio of all of them like they change in a like they all change by the same amount, so it doesn't matter when you divide them. They all simplify out to be like one
So
thing.
we will have to make the conclusion. The triangular trigonometric ratio depends upon
The angle.
the angles. Okay. Now ratio is.
Okay.
Let me give you the example. So by virtue of the numbers, we may have be a wrong conception about that, that if you have the bigger values, the ratio will be the greater. What I mean to say, as we have seen in this, that these sides are different, quite different from these. So we are every time doubling, we are adding three more to each and every one. Here five more to each and every one. Here we are adding four to
Yeah.
each and every time to the side. So we are increasing the lengths, the sizes of the dimensions of these three triangles. But one thing is that we are keeping the angle constant. What I mean to say, the angle remains the same in each and every triangle. So ratio is actually, when you are increasing both the quantities, there is no difference. Let me give you the example. If you just want to make a cold drink, only one glass of cold drink. So you are mixing
Right.
the five table, what we can say, the tablespoon of sugar to
Okay.
one glass of water. So if you will have to,
Okay.
if you will have to make the six glasses, so what you will have to,
You would like scale it
five
up.
five time add the sugar, 5 teaspoon multiplied by 6, and
Yeah. For
6 glasses, five
yeah.
more glasses over there, but the ratio will remain the same. If you are checking the one glass and of the jug of 6 glasses, the chemical analysis will tell you the whole story, that the ratio is 5 to 1 to 5. Okay.
Right.
So in this way,
Okay.
similar, from here, what we can say, please read this one.
Sure. Um, conjuncture
Yes.
trigonometric ratios are a property of similarity angles and not of the length of the sides of a triangle.
So this is what we can say, the conjecture. The trigonometric ratios are a property of similarity angles and not of the
Right.
length of the sides of the right angle. So it's totally depending upon the measurement of the angle. So you are increasing or decreasing the angle, you will get the different values. So the
Right. Yeah.
ratios are totally dependent on the angles, not the sides. So it's a basic thing.
Yeah.
Now, please
Sure.
read. Computed.
Computed trig
in-
ratios. The
Yes.
trig ratios are used so often that technology makes these values readily available in form of tables on scientific calculators. We will now show you how to use your calculator to find some trig ratios.
Yes.
Grab a scientific calculator and try it out.
Okay.
Let me check
Any.
if my. I think mine actually might be dead right now.
Okay.
I was using it this morning.
You have the calculator now, just now.
Not right now because
Okay.
mine just like died yesterday.
Anyhow, it's no problem. Next time you will get the calculator, so you can make it.
Yeah.
Anyhow, finding the trigonometric values on calculator. Please read this one.
Sure. Each calculator brand may work a little differently, but results will be the same. Look for trig functions um, on your calculator: sin, cosine, and tangent. Yeah, I see them. Like I have my like I could see it, but it's just not alive.
Yes.
Okay.
Okay.
Select trig ratio of your choice, followed by the angle in degrees, and execute. Enter. Example: sin 30 will display point zero 0.5. On some calculators, you may have to type in the angle first, then the ratio. Example: 30 sin will display as 0.5.
Okay. So which one is your, that you will have to,
Uh,
in this way
yeah,
or
I'll have
that
to
way?
figure that out.
Okay. Anyhow,
Um,
anyhow,
because
anyhow,
it's dead right now. Yeah.
anyhow. Next one is, we are just one more. Okay, look at this.
Okay. Use your calculator to verify that the sin, cosine, and tangent of the following angles are correct to 4 decimals. Okay, well, I can't really do that right now, but
Okay,
I
okay.
guess I could
Anyhow,
just read
it's
these or
just you can do this one, but when I was
yeah.
there in school, so at that time I haven't any, I had not any that type of the calculator over there, the scientific calculator. So how I was using these values, how I was calculating these five to six, almost six values. So we have devised the technique. I will tell you that. That was totally
Oh, okay.
manually, without any calculation. We can find all these values without using the calculator. So I will tell you. I will draw the table. Automatically, you will get all these values. Anyhow, this I will do for you next time.
Okay.
I will tell you the technique. At that time, we don't have the calculator. If you don't have the calculator, so how you can make the calculation? Anyhow,
Exactly.
try it yourself, calculator. So once again, the same thing is that you will have to press the sign in 34. You will have to change the mode of your calculator to the degree measurements of the angles, because basically in the calculator we have a shift button just to change the functionality. What I mean to say, the angles can be measures in gradient, radian, and what I mean to say, the degree. So these are the three angles measure mode. That is the degree, the radian, and the gradient. So you will have to check your calculator before
All right,
making
yeah.
all these calculation. If you are just punching the sign mark over there on your calculator, that button, push that, then put the value, sign 30, 34, you will get, execute the value, you will get the answer of all these things. So
Okay.
it's all about the calculator. Anyhow, uh, okay, now going back, please read this one, but why we are going back.
Sure. Going backwards, finding inverses. We can use the inverse operation of a trig ratio to find the angle with the known ratio n over m. The inverse trig ratios are as follows: inverse of sin n over m is sin uh, to the power of -1 n divided by m. Inverse of cosine n over m is cosine power of 1 -1 is equal to or times n over m. And then inverse of tan n over m is tan minus 1 n divided by m.
Yes, so these are the sine inverse of this. So you will get the angle, measure of the angle. If these two numbers are given, the values are given, so we are just looking for the angle, so we can also find the angle. Anyhow, that is the sine inverse of this ratio, cosine inverse of this, and the tangent inverse of this, we can find the angle. Look at this. So example inverse operation sine of A. Please read this one. Suppose.
Sure. Suppose we know the trig ratio and want to find the association uh, with angle A. We have the opposite side and the hypotenuse. Therefore, SOH so part helps us know that we use sin A equal over H is equal to 4 divided by 5. The inverse, thus sin minus 1, 4 over 5 is equal to A. A sin minus 1, 4 over 5 is equal to 53.13.
Are you getting this?
Yeah, you just input the so if it's inverted like inverse, then you just put the minus 1 button
No,
instead.
sign inverse, no need to put the minus. There is a shift button over there. When you are looking for the
Yeah, yeah,
inverse
it's like
values,
right there. Yeah,
okay, sign inverse. We are not just calling it as sign raised to power minus 1. It's a
yeah,
sign
it's like if you
inverse. It's
click,
an
yeah,
inverse. Inverse functions are also available if you are for the inverse function. So you will have to press the shift button and sign inverse will be there, and put the values, put the ratio, you will get the answer. So this is the sign inverse that is automatically available on the calculator. So
yeah, I see
example
that.
of this cause.
Okay,
Please.
example of inverse
Yes, please
operation
read
cosine
quickly.
B.
Yes.
Okay, suppose we know the trig ratio and what we want to find the associated angle B. From SOHCAHTOA, we know that from the angle B we have adjacent side and the hypotenuse. Therefore, co part helps us know that we use cosine A over H is equal to 4 over 5. That we use cosine, oh wait, the inverse is thus cosine, like inverted or inverse cosine, and then 4 over 5 is equal to b. B is equal to the cosine uh, minus 1,
Cosine
4,
inverse of 4
uh,
by 5. You should say
yeah,
cosine inverse of 4 over 5.
inverse. Okay, so cosine inverse 4 over 5 is equal to 36.87.
Yes, this will be the value on the calculator. So for the tangent is the same story. No need to repeat that. Try yourself. You will have to make use of the calculator. Anyhow, I will send these slides also, and there is a recap video for this lesson is also. So I will send both of these today. Finding the legs of a right angle. No, this is very important. Now please read this one.
Okay, use the trig ratios. Use the trig ratios to find the sides of a triangle. Remember SOHCAHTOA with the reference to angle AB is the length of the side adjacent. A is the length of the opposite the angle. The hypotenuse is given. Strategy: make an equation that uses only one leg and hypotenuse at a time.
So we will have this time we are looking for the side, not for the ratio. Yes,
Right.
please.
1 second. My video is like lagging. Okay. Use tangent. Substituting values from the triangle, tan 30 degrees is equal to A over B. From the calculator, tan 30 is equal to 0.5774. Thus, tan 30 degrees is equal to A over B. 0.5774 is equal to A over B, and A is equal to 0.5774 times B gets you stuck,
Really? Are you?
right?
For this? Are you
Yeah,
getting
it gets
this?
you stuck. Yeah, yeah,
Where you will have just to any one of the value. If any one of the value is given, yes, here you are not getting the answer. The reason is this
right.
that you need the one value. If B is given, you
Mhm.
can find the A. If A is given, you
Yeah,
can find the B. So one more value is required over here. So
yeah,
you are not getting the answer. The reason is that you are looking for the one value. So two must be given. The one is also given over here. So that's why you cannot find the tangent. But the other way, if you are looking for the sine, so you can find the sine of this. I'm sure you can find the cosine of this also. Anyhow,
right.
look at this. Now,
Okay.
please read.
Finding the legs continued. Um, use the sine ratio to find the leg of a triangle. Remember SOHCAHTOA. Use sine A is equal to over 8. Substituting values from the triangle, sin or sine 30 is equal to A divided by 12. From the calculator, sine 30 is equal to 0 0.5. Thus, sine 30 is equal to A divided by 12. 0 0.5 equals A divided by 12. And A is equal to 0 0.5 times 12 is equal to 6.
So this time you are not stuck up
Right.
because
Because
you
you
are
have
looking for
the two values.
two values. You are looking for the sine. Similarly, you can find out the cosine also. But when you
Cosine,
are
right.
looking for the tangent, you will not get the answer.
Yeah.
So this is what we can say for the cosine. So this is the same. You can find out. Try it yourself. So I will send. Then you will have to try when you have the calculator.
Okay.
So do it in your own
Yeah.
time. So finding the hypotenuse. If you are looking for the hypotenuse, how will you find this? Please read this one quickly.
Use trig ratios to find the hypotenuse of a triangle. Remember SOHCAHTOA. With reference to angle A, B is the length of the side adjacent, and 12 is the length of the side opposite to the angle. Uh, A C is the hypotenuse. Strategy: make an equation that uses one unknown at a time.
at a time. Now let's see. We can find out C by using the trigonometric ratios. What I mean to say that what is that? That sine. By using the sine, we can find out. Okay. Look at this. How can we find out? Please.
Sure. Since 12 is opposite to the angle, we use the sine ratio. Sine sine is equal to O over H. Substituting values from the triangle, sine 30 is equal to 12 divided by c. From the calculator, sine 30 is equal to 0.5. Thus, the sine 30 equals 12 divided by c, or zero point 0.5 is equal to 12 divided by c. C is equal to 12 divided by 0.5 equals 24.
Are you getting this?
Yeah,
You can make the calculation. It's very simple. By using the ratios, we
right,
can find the length of the side, any side. So this is for
right.
you, and putting it all together. Now look at this. Please read this quickly.
Sure. Now we have the tools to we need to solve any right triangle. Uh, why is it lagging so hard? I don't know. My screen keeps going blurry for some reason. Could you read the rest of it?
Okay,
Because it's
we
like
now have the tools we need to solve any right triangle to determine the lengths of each and all sides and the angles given minimal uh, information. Remember, Soko, Choho, Toha, typically you get two pieces of information, one side length and one angle, or two sides lengths. So basically, this slide is saying that we have the techniques, we have the tools that whenever the triangle is there, the one angle is right angle. If the other angle is given, the sides, any two sides given, we can find the ratios, we can find the length of the side, any side, we can find the angle. So a lot of things can be determined by using these trigonometric ratios. So solving the triangle, side plus angle, if the angle and side is given, we once again can make use of SOH, CA, TOA. So we can get the calculation and we can also find the angles. So let's see. Uh, Very quickly, you can solve this. I will send you this. And this is the trial for you, and solve this triangle. Once again, we are repeating that Pythagoras theorem, and this one is also there, and solve this. So try yourself, real life application. Can you see my screen now?
yeah, it's still kind of blurry, but I can try reading it still if you want.
Please, just read this one. We are just
Sure.
about to end it.
Trigonometry is used to solve real life problems. The following slides show a few examples where trigonometry is used. Search the internet for more examples if you'd like.
This, we can solve this. Measure the height of a tree. What would you need to know in order to calculate the height of this tree? What triangle ratio would be used? So this is the triangle. Let's suppose if you
Okay.
are looking for the height, so you will
Right.
have to know this angle. This is called the angle of elevation. If you can
Okay.
measure
Yeah.
the distance, if you have this measuring strip, so just stand over here, measure the distance, and you can find the height, because you can measure the distance
Right.
on the ground very easily. You can also set the
Yeah.
angle to the top, and no need
Right.
to measure from here and there.
Yeah.
There's
The
a
tree.
very high
Yeah.
tree. So you can make use of this right angle triangle. So which ratio is being used over here? If the theta is
Uh.
given, this side is given, I think tangent theta is h over x. So you can find the
Right.
h when x is given, tangent theta is given also. Okay,
Right. Yeah.
so tangent
Okay.
theta
That
is
makes
the
sense too. Yeah.
appropriate ratio. Then, if you, this type of a problem is two buildings, skyscrapers, cars, and mountains, you can also calculate the heights of this mountain. You can calculate the skyscraper heights, so angle of elevation, using this
Right.
distance from where you are standing. So we'll do this. You can also find the distance between the two persons. So please read this one. This is especially for you.
Sure.
From here.
You have be proud of yourself. You have successfully completed crash course in basic trigonometry, and I expect you to be able to do well in this strand in the United States standard test. Print the certificate to show your achievement.
So are you agree with this?
Yeah, I think so. Seems about right.
Read this.
Wow, you actually made an entire certificate. That's pretty cool.
Anyhow, it's just we have started that you are just learning the basic tricks of trigonometries, and definitely these type of the question. When I usual that question will come back to that one. So definitely by using all these ratios, so you will be able to find the answer very quickly. What I mean to say.
Yeah,
So
I
you can
think so
get the
too. Yeah.
print of this, keep with this that you have done each and everything about the trigonometric ratios only. Trigonometry is a very big and very large branch, but anyhow, you can say that at least the introduction to trigonometry, I can make a right angle triangle to can find the ratio of sine, cosine, and so on. That's all
Right.
about that. So anyhow, thank you very much. So this was a slightly
Yeah.
lengthy. We were going very quickly, and definitely that was the recall of your previous knowledge. So that may
Yeah.
be
I
a
remember. Yeah.
okay. Anyhow, thank you very much. I will send all these slides, and I will send the recap video, very brief video about all these things. So from there, you can learn more things which we have missed over here. That will be there over in the recap movie, you can click and you can just link to the one more thing is that we are planning that great debate, so a lot of learned persons are over there participating, so you must be the active participants of that also, so you will have to send me the Facebook ID that that time I can invite you. And one more thing is that you will have to let me the right time and the date, the day. Ideally, that must be the Saturday night over here in Pakistan, and that might be afternoon in your, what we can say, in your city.
Right.
Are you getting me? What I'm
Yeah. I
saying?
got you.
So you will have to tell me. I would say ideally, if that is a Saturday night for us, can you
Yeah.
spare
Okay.
that time?
I should be. Yeah. I should be able to. I don't think if I'm busy or something, which I don't think we will be.
Okay,
Uh,
you will
I'll,
have to tell the timing prior to that, that we should intimate the other participants that they must be, because when after the 9 p.m. at 10, ideally what I am suggesting that that must be 10 p.m. over here in Pakistan. So what will be the time over there? 10 p.m. over here in Pakistan. So that must be 12 over there.
yeah. Around that time.
Okay, okay. So if you can spare that from this hour, 12 to what I mean to say 40 or 30 minutes onward.
Yeah. Yeah.
So you
I
will
think
have to,
so. I should be
so,
able to. Yeah.
we are tentatively making this advertisement that Saturday, this Saturday, 12 noon in America and 10 p.m. at Pakistan Standard Time, we will be on live on Facebook and that great debate, because I have, what I mean to say, almost 3,000 plus friends. So they
Right.
can attend a lot of my teachers and legendary people are over there. They are connected, and I am
Right.
also inviting some other ones. So you will be there, and the gentleman who is delivering this psycho linguistic, a very good presentation, a live debate. Many people will ask the question. You can also, you will enjoy it. Oh, I hope.
Okay.
Okay, anyhow, thank you very much for today. It's time to say
Yeah, you're welcome.
goodbye. Allah Hafiz.
Okay. Allah Hafiz.